Hello my friends and welcome back to the You Can Do TV channel. Construction of the 4,320 megawatts Dasu hydropower project is progressing as per schedule. Diversion tunnels are nearing completion to facilitate Indus River diversion. Key activities include starter dam cutoff wall, operational crushing plant, road construction, and development of WAPDA colony and residential buildings. All works are proceeding according to the approved PCI timeline and engineering protocols. The tunnel boring machine, TBM, used by WSDOT, is a mechanized system designed for precision underground excavation. Operating with a rotating cutter head, the TBM simultaneously excavates soil or rock while installing precast concrete segments to form a continuous tunnel lining. It minimizes surface disruption, uses conveyors to remove spoil muck, and ensures structural integrity by placing rings with vacuum-assisted systems. DYWIDAG post-tensioning systems provide high pre-stressing forces and accommodate long tendon lengths for bridge construction, especially in Eastern Europe. Installation requires hydraulic jacks and pumps operating at near maximum capacity, with regular servicing to ensure reliability. Proper grouting is critical for durability and corrosion protection. DYWIDAG's stay cable systems, such as Dynabond and Dynagrip, offer replaceability and high fatigue resistance. These systems were utilized in the 570-meter main span of Scotland's Skye Bridge, supporting efficient, lightweight cable-stayed structures. The replacement construction of the Rheinbrück-Neuenkamp on the A40 is a crucial part of the traffic corridor between Rotterdam and Duisburg. Due to increasing traffic loads, the existing bridge no longer meets requirements. Planning by DEGES began in 2015, and construction started in 2020 by Hochtief. The work commenced with foundations, abutments, and 7 main piers, supported by temporary auxiliary piers. After completing the northern superstructure, the southern bridge will be laterally shifted into its final position and the temporary piers removed. The steel structure consists of 297 large components totaling 13,600 tons, delivered just in time from several European plants including MCE Slaney in the Czech Republic. A detailed surveying concept ensures precise fit during assembly. Nearly 350 heavy transports delivered the parts at night. Construction methods combine incremental launching and balanced cantilever construction. The 4 pylons, each 70 meters high and made up of 48 segments weighing 1,650 tons, are supported by 80 stay cables, totaling 723 kilometers of steel strands. The bridge spans 812 meters in length and 68.25 meters in width and is scheduled for completion by 2026. Sustainability measures include significant CO2 reductions in materials. On the Melbourne Metro Tunnel Project, a CFA, continuous flight auger rig, was used to install 1,200mm diameter piles with impressive efficiency. This method ensures minimal soil displacement and excellent verticality. The rapid pile breakdown phase was executed using Australian pile croppers, which delivered precise, controlled cropping with no damage to reinforcement. Their performance demonstrated how modern hydraulic cropping eliminates the labor-intensive and hazardous manual methods of the past. The clean finish at cut level facilitated faster construction of pile caps and reduced the need for additional concrete trimming. This efficient process showcases how integrated piling and cropping technology has revolutionized foundation works, especially in tight, urban rail environments, where speed, safety, and precision are critical. The foundations and piers are cast in place, firmly bonded to the foundations below. Once the design depth is reached, the reinforcement is lowered and the concrete is finished with tremie pipes to ensure continuity and uniformity. This process is accompanied by technical regulations, ensuring the stability. The lifting operation for the Strabane foot and cycle bridge utilized heavy-duty cranes, including a 750-ton lever and a 500-ton lever, performing a tandem lift of the primary 100-ton bridge arch. Ancillary bridge sections, each weighing up to 20 tons, were lifted using a 350-ton Terex Demeg crane. The tandem lift required precise synchronization between the two lever cranes to ensure balanced load distribution and stability throughout the maneuver. Rigorous planning and engineering assessments preceded the lifts to verify the structural integrity of both the bridge components and lifting equipment. The 350-ton Terex Demag crane handled smaller sections, such as deck panels and support structures, facilitating their accurate positioning for final assembly. Comprehensive risk assessments and adherence to safety protocols minimized hazards during the lifting operations. All cranes operated under strict guidelines, following manufacturer specifications and industry standards. The RU800S is a high-performance rail-mounted track renewal train developed by Placer and Thierer. Designed for continuous track relaying, it integrates old track removal, ballast cleaning, and new track laying into a single automated process. The RU800S features a modular design, high throughput, and minimal manual intervention. Its synchronized operation ensures precise alignment, tamping, and compaction of the newly laid track. Widely used across Europe, it significantly reduces track possession time, improves safety, and enhances efficiency in large-scale rail infrastructure upgrades. The EDFC mechanized track laying on Lot 102 Padan involves advanced construction techniques to ensure efficient and precise installation of railway tracks. The process begins with site preparation, including leveling and compacting the track bed to achieve optimal stability. Specialized mechanized equipment, such as track laying machines and ballast regulators, are employed to streamline the laying of sleepers and rails. Rails are delivered in pre-assembled panels or long-welded lengths, which are carefully positioned and aligned using laser-guided systems to maintain the required track geometry. Sleepers are then fixed securely to support the rails, ensuring proper gauge and alignment throughout the track length. Ballast is distributed evenly beneath and around the sleepers using mechanized ballast regulators, providing essential drainage and track stability. Continuous quality checks are conducted during installation to verify alignment, gauge, and structural integrity. The mechanized approach significantly accelerates the construction timeline while improving safety and consistency. This modern track laying method on Lot 102 Padan enhances operational reliability and supports increased rail traffic capacity for the region's transportation infrastructure. The SPS milling and paving process for parking lots involves a detailed, technically controlled sequence to ensure durability, aesthetics, and compliance. It begins with the implementation of professional traffic control to protect site users during construction. Once the area is secured, surface milling is performed using state-of-the-art equipment, capable of removing asphalt at precise depths for uniformity and optimal results. The milling machines feature water systems to control dust emissions. Following milling, a thorough cleaning process ensures a debris-free surface, critical for the adhesion of the new asphalt overlay. A commercial-grade tack oil is applied to bond the layers, enhancing pavement longevity. The paving crew then applies the asphalt using technologically advanced pavers equipped with sensors for depth, rate, and joint consistency. Dump trucks supply the hot mix continuously, while the paver lays it evenly. Compaction is executed with vibratory rollers using correct patterns, speed, and timing, ensuring density for structural integrity under varying weather conditions. After paving, expert striping crews apply traffic markings using precision equipment, conforming to ADA standards. Throughout, quality control and attention to detail guarantee long-lasting professional results, hallmarks of the SPS approach.
The AFW150G footpath paver is a specialized machine designed for compact job sites, particularly suited for footpath paving and small road repairs. The video showcases its first day in operation on a new site in Cambridge. This mini road paver is a wheeled model featuring a unique combination of simple design and proven technology. It is especially effective for small-scale applications like footpaths, cycle tracks, trenches, and paving in narrow or restricted spaces. Its compact design allows it to operate efficiently in single lanes with minimal traffic disruption. The AFW150G is equipped with 3 wheels, 2 rear wheels for traction and a single front wheel for steering. The paver features a fixed hopper that can be side-loaded by a skid loader, and the operator stands on a rear platform to drive the machine. It is powered by an air-cooled diesel engine with an electric start-stop function, which is integrated with hydraulic pumps for its operations. The hydrostatic transmission system includes a variable flow rate pump that drives 2 orbital motors, which in turn are connected to the planetary drives for traction. The progressive start and stop of the machine are controlled hydraulically via proportional control mounted on the variable flow pump. The Miller M8800 slip-forming machine is a highly efficient piece of equipment used for pouring concrete barriers. On the Belt Parkway in New York, it was employed to construct single-slope median barriers for mill basin constructors. The M-8800's operation involves continuous movement along a predetermined path, while concrete is fed into the machine. The slip-forming process involves the concrete being extruded through a mold, which shapes it into the desired profile as the machine progresses. The M8800 ensures a consistent and smooth finish by vibrating the concrete to remove air pockets and ensure uniform compaction. Its automated steering and grade control systems maintain precise alignment and elevation, which is crucial for the uniformity of median barriers. On the Garden State Parkway at mile marker 40.00, the M8800 poured approximately 3,000 linear feet of variable height median barrier. Cold-in-place recycling, CIR, of a chip-sealed pavement with added coarse aggregate enhances pavement structure and longevity. In this project, 1.25 inches of coarse aggregate was incorporated to bolster the structural integrity of the pavement. The recycling process utilized CSS1 emulsion, a slow-setting asphalt emulsion, which aids in binding the existing pavement material with the new aggregate. The Wirtgen County Route 3800 recycler was employed for this purpose, effectively milling and mixing the existing pavement with the emulsion and aggregate. To ensure smooth and efficient material handling, a Weiler-Windrow elevator was used to transfer the mixed material into the paver. The final paving was performed by a Vogel Vision paver, known for its precision and capability in achieving uniform surface finishes. Using a grading beam with an excavator can significantly boost productivity. The grading beam enhances the excavator's capability to level surfaces quickly and accurately, reducing the time required for manual grading tasks. It allows for a more uniform and smooth finish, minimizing the need for additional passes and rework. By attaching a grading beam, the excavator can cover a larger area in a single sweep, improving efficiency on construction sites. Additionally, the grading beam can be used for a variety of tasks, including spreading materials, leveling subgrades, and preparing surfaces for paving or landscaping. This versatility means that the excavator can handle more tasks without needing to switch equipment, further saving time and increasing overall productivity. The precise control offered by the grading beam also reduces operator fatigue, leading to more consistent performance and fewer errors. The Leeboy Box Laydown Machine is a compact and efficient asphalt paver designed for small to medium-sized paving projects. Known for its reliability and ease of use, this machine excels in tight spaces and quick jobs, offering precise control and a smooth finish. Its robust construction ensures durability, while the user-friendly interface allows for straightforward operation. This vibratory screed is essential in road concrete pouring projects. It compacts and levels the concrete surface effectively, capable of handling up to 20 centimeters in height. The screed is equipped with a manual start and 2 levers to pull cables, facilitating ease of operation. With a weight of 137 kilograms, it spans a length of 4.5 meters to 7.5 meters, ensuring efficient coverage and uniformity in concrete leveling. The JPS construction method is a patented approach to constructing high-quality floor slabs, focusing on large area finishing through mechanized processes. This method incorporates several advanced techniques to ensure a superior finish with minimal unevenness and exceptional durability. One of the standout features of the JPS method is its ability to achieve a flat surface finish with minimal convex and concave deviations. This is accomplished through the use of vibrators during the construction process, which help to evenly distribute the concrete and eliminate irregularities. The use of vibrators ensures that the concrete settles uniformly, creating a smooth and consistent surface that is essential for both functionality and aesthetics. Another significant advantage of the JPS construction method is the incorporation of a special surface modifier and revibration compaction. This process enhances the floor slab's abrasion resistance, surface strength, and water tightness. The surface modifier is a specially formulated compound that is applied to the concrete surface to enhance its properties. The revibration compaction technique further consolidates the concrete, ensuring that it is densely packed and free of voids. This results in a floor slab that is not only strong and durable but also highly resistant to wear and tear. The excellent abrasion resistance and surface strength achieved through the JPS method make exposed finishing possible. This means that the floor slab can be left as is, without the need for additional coverings or finishes, while still maintaining its aesthetic appeal and functional properties. This is particularly advantageous in industrial and commercial settings where durability and ease of maintenance are critical. Furthermore, the JPS construction method ensures that there is no weak layer, such as latents, on the surface of the floor slab. Latents is a weak, powdery layer that can form on the surface of concrete during curing, compromising the adhesion of finishing materials. By eliminating this weak layer, the JPS method provides a robust and stable base for the application of various finishing materials, such as painted floors. This ensures long-term adhesion and stability, reducing the need for frequent repairs or maintenance.
At a high-rise construction site in downtown Seattle, local 528 cement masons execute a precision concrete pour on the 30th floor deck. The operation begins with calibrated coordination between ready-mix trucks and the boom pump, which delivers the mix through a multi-stage pipeline system. Masons manage placement using vibrating screeds to ensure proper consolidation and eliminate entrapped air. Edge finishers follow with hand tools, maintaining tight tolerances at slab boundaries adjacent to safety rails and formwork. Power trowels are deployed in a staggered pattern to achieve surface flatness and specified finish levels, often in accordance with FF/Florida standards. Environmental conditions, wind, ambient temperature, and concrete temperature are continuously monitored to adjust set time and finishing sequence. Communication is maintained via radio to synchronize pump output, mix delivery rate, and crew pacing. Safety is enforced through tie-offs, PPE, and deck perimeter controls due to the elevation. Each pour follows a sequence: layout, placement, strike-off, bull floating, edging, machine troweling, and curing compound application. By integrating skilled manual craftsmanship with mechanized equipment, Local 528 ensures structural slab integrity, optimal finish quality, and adherence to project timelines. This process is repeated floor by floor as the building climbs, forming the structural backbone of the high-rise. Dangote Refinery, covering 26 square kilometers in Nigeria's Lekki Free Zone, is the world's largest single-train refinery. It processes millions of barrels of crude oil daily, significantly reducing fuel imports. Memowit managed over 1,000 heavy lifts, including 30 lifts exceeding 1,000 tons, ensuring efficient, safe transport and installation throughout construction. Covering 500,000 square meters, sustainable ground reinforcement was applied to support heavy lifts. Project Q1051 involves the installation of large-diameter steel tubular piles, each up to 12.5 meters in length, as foundation elements for a major LNG process plant in northern Australia. These piles form the deep foundation system required to support heavy plant structures, storage tanks, and modules on soils with low surface-bearing capacity. The steel tubes, typically ranging from 600 millimeters to over 1,200 millimeters in diameter, are fabricated from high-strength structural-grade carbon steel and delivered to site with full mill certifications. Installation is executed using hydraulic impact hammers mounted on crawler cranes or piling rigs, ensuring precise verticality and driving energy. Each pile is installed to engineer depth or resistance, with blow counts and driving logs recorded to confirm load-bearing performance. In cases requiring deeper embedment, full penetration welds are applied on-site to splice additional sections, followed by non-destructive weld inspections. Once driven, piles are trimmed to cutoff levels and incorporated into pile caps or structural bases. The piling operation is coordinated under strict safety and environmental controls, accounting for marine proximity, noise, and vibration. The method ensures a stable and durable foundation system capable of withstanding both static and dynamic operational loads typical of LNG facilities. The Aasta Hansteen field, located in the Norwegian Sea at a depth of 1,300 meters, features a deep-water gas development with a spar platform. the first of its kind on the Norwegian continental shelf. Operated by Equinor, it includes subsea wells tied back to the Spar, enabling efficient gas production and export to Nyhamna. The Wheatstone project in Western Australia, led by Chevron, marked a major milestone in Australia's LNG industry. Following the final investment decision, FID, in September 2011, early works commenced with the construction of roads, worker accommodations, and water infrastructure. Key components were fabricated globally: LNG modules in Tianjin, China, and platform topsides in Okpo, Korea. The platform topsides were transported and installed via float-over onto the steel gravity structure, SGS. Drilling operations for the Wheatstone and Iago gas wells were conducted using the Atwood Osprey rig. Subsea infrastructure included spool and flowline tie-ins. Critical plant components like LNG storage tanks, gas turbine generators, and processing modules were installed. The site also featured an operations center, laboratory, materials offloading facility, and LNG export jetty. The first LNG cargo was loaded and sailed away in October 2017. Footage showcasing the construction of Chandrayaan-2 highlights the intricate assembly of its orbiter, lander, and rover components. Advanced cleanroom environments ensured precision manufacturing and integration. Engineers meticulously tested propulsion systems, communication modules, and scientific instruments. The video captures robotic arms, specialized welding, and calibration processes. Rigorous quality checks and simulations verified mission readiness. This comprehensive footage demonstrates the complexity and technological expertise behind India's second lunar exploration mission, reflecting years of research, development, and collaboration. The Ravenscraig West Coast Mainline Bridge construction followed a precise, multi-stage process to ensure structural integrity and safety. Initial activities focused on site preparation, which included clearing vegetation, earthworks, and soil stabilization to provide a solid base for foundations. Deep foundation piles were driven or drilled into the ground to support the substantial loads of the bridge, with careful alignment and load testing to verify capacity. Prefabricated steel girders, fabricated off-site to exact specifications, were transported to the construction site. Using heavy-duty cranes, these girders were lifted and positioned onto the prepared foundations. Temporary works, such as scaffolding and falsework, were installed to support the girders during assembly and concrete deck construction. Concrete was poured and reinforced with steel rebar to form the bridge deck, ensuring high strength and durability. Waterproofing membranes were applied to protect the structure from water ingress, while integrated drainage systems managed surface runoff. Following deck completion, safety barriers, parapets, and rail track adjustments were installed. Throughout construction, quality assurance protocols and continuous structural monitoring ensured compliance with engineering standards and safety regulations. Final inspections and load testing validated the bridge's readiness, allowing for safe operation and improved rail connectivity on the West Coast Main Line. The Yusufeli Dam on the Koru River, Turkey's tallest and the world's fifth highest at 275 meters, harnesses powerful hydroelectric energy. The Yusufeli Dam in Turkey is a 275-meter-high hydroelectric project with a 2.13 billion cubic meters reservoir capacity. It generates 1.9 billion kilowatt-hours annually, powering 2.5 million people. The Ready Rock retaining wall system features large, interlocking precast concrete blocks designed to mimic natural stone. They are transported and precisely placed using excavators. It provides structural strength, easy installation. The Lightform ICF basic assembly and installation process begins with careful footing and pad preparation to ensure a stable foundation. The first coarse corner assembly is critical for accurate alignment, followed by the second coarse corner assembly to build wall height. Vertical bracing and work platforms are installed to provide structural support and safe access during construction. Window and door bracing ensure openings maintain correct dimensions under load. A quick checklist verifies all components are properly installed before concrete pouring. Concrete specifications must meet project requirements, and accurate calculation of concrete yards is essential for material planning. Waterproofing is applied to prevent moisture infiltration, protecting the structure's integrity. Electrical and plumbing conduits are integrated within the ICF walls before concrete placement. Finally, finishing processes prepare the wall surfaces for subsequent treatments, ensuring a durable and efficient insulated concrete form system. In India's mountain road construction, hard rock is excavated using powerful excavators. The big rock is pushed downhill into nearby riverbeds, enabling faster progress in steep, rugged border terrains. The Bucher Schorling City Fant 6000 mounted on a MAZ chassis is a high-performance, heavy-duty street sweeper designed for demanding urban and industrial cleaning operations. Built for efficiency and durability, the unit features a 6 cubic meters hopper capacity, enabling extended sweeping without frequent unloading. The robust MAZ chassis provides a stable and reliable platform, ideal for Eastern European road conditions and municipal applications. The water spray system reduces dust emissions, ensuring compliance with environmental regulations. The sweeper's hydraulic system enables precise control of all sweeping and suction operations from the driver's cabin, increasing operator comfort and productivity. Equipped with a powerful suction fan, wide sweeping width, and dual side brushes, the CityFant 6000 ensures effective debris collection along curbs, road edges, and flat surfaces. Thanks to its high-capacity suction fan and reinforced suction nozzle, the machine can effectively collect large, dense objects without clogging or damaging the system. The integration of Bucher's advanced sweeping technology with the cost-effective and serviceable MAZ chassis offers a practical solution for municipalities seeking modern street cleaning capabilities without compromising affordability. This combination reflects a balance between Western technology and local operating needs. During anchoring near Panama, USCGC Diligence experienced a runaway anchor. Over 600 feet of chain paid out due to a brake failure. With only one shot, 90 feet left, the crew acted quickly, narrowly avoiding disaster. Excellent response under pressure.
The CAT 994K wheel loader, delivered by Hastings Deering, stands out as a pinnacle of heavy machinery engineering. With its robust design and spacious, comfortable cab, the 994K is tailored for demanding coal operations, featuring an oversized 40 cubic meter bucket, more than doubling the payload capacity of its predecessor, which had a 16 cubic meter bucket. This enhancement significantly increases efficiency, reducing the number of passes required to load a 789C haul truck from 10 to just 4. Performance-wise, the 994K is a powerhouse. It boasts 500 additional horsepower compared to earlier models, allowing for faster and more efficient loading operations. This increased power translates directly into operational efficiency and cost savings, critical factors in the mining industry where every minute of downtime affects profitability. The machine's advanced emission controls reflect Caterpillar's commitment to environmental sustainability, delivering better exhaust emissions and contributing to reduced environmental impact. Comfort and operator well-being are prioritized in the 994K's design. In the construction of a new 17-story condo building in uptown White Rock, a unique and efficient method for removing dirt from a deep excavation has been employed. This method involves the use of two excavators working in tandem, known as the buddy system. One excavator, positioned at a lower level, reaches into the excavation to scoop up the dirt. It then passes the dirt to a second excavator, positioned closer to the edge of the excavation.
Thing's been lowered in there. There's nowhere down.
This second excavator then transfers the dirt to a dump truck or another designated area. This collaborative approach significantly enhances the efficiency and safety of the excavation process, especially in deep and confined spaces where a single excavator might struggle to operate effectively. By working together, the excavators can quickly and effectively remove large volumes of dirt, ensuring that the project progresses smoothly and on schedule. The Vermeer T1255, equipped with a trencher, is a powerful machine designed for challenging excavation tasks. In action in Las Vegas, this formidable piece of equipment demonstrates its capabilities by efficiently excavating rock. The T1255 features a robust trencher that slices through hard surfaces with precision, making it ideal for projects requiring trenching in rocky terrains. Its hydrostatic transmission ensures smooth operation, while the Tech Plus electronic control system optimizes machine performance. The T1255's impressive horsepower and trenching depth make it a preferred choice for contractors working in demanding conditions. The Conveyored Road Cloth Placement Technology, CRCPT, developed by Byron Kelly in Klickitat County, Washington, revolutionizes the installation of geosynthetic cloth for road construction. This innovative method utilizes a specially designed truck equipped with a conveyor system that unrolls and places the geosynthetic fabric with precision and efficiency. The CRCPT minimizes manual labor and ensures consistent placement, enhancing the quality and longevity of road construction projects. By automating the deployment process, CRCPT reduces installation time, lowers costs, and improves safety for workers. This technology is particularly beneficial in large-scale infrastructure projects where speed and accuracy are critical. The CAT D11 dozer is a powerhouse in the world of heavy machinery, offering higher productivity at a reduced cost. With innovations like the torque divider and stator clutch, it enhances drivetrain efficiency and lowers fuel consumption. The load-sensing hydraulics deliver more power to the dozer, increasing responsiveness and boosting fuel efficiency. One of the standout features of the D11 is its high-horsepower reverse, which accelerates non-productive traveling, reducing cycle times and increasing productivity by nearly 8%. Additionally, the advanced stator clutch torque converter contributes to an 8% boost in overall efficiency. Maintenance and repair costs are up to 5% lower due to the new case and frame design, improved bearings, redesigned pin joints, and a 30% larger oil pan. The in-cab multifunction touchscreen display allows operators to monitor machine performance and adjust parameters for optimal task performance. The JCB Fast Track Snowplow is a high-speed machine designed to dominate snow removal. Built for efficiency and speed, the Fast Track can reach speeds of 40 to 50 miles per hour depending on its factory specifications. JCB has been manufacturing the Fast Track since 1991, primarily for European farmers who need to travel significant distances to their fields. What sets the Fast Track apart is its unique suspension system. The front suspension features a 4-link setup with a panhard rod and an anti-roll bar, while the rear suspension employs a triangulated 4-link with an anti-roll bar. This advanced suspension allows the Fast Track to operate at high speeds without compromising the comfort and safety of the operator. Additionally, the Fast Track is equipped with disc brakes and an air-suspended seat, further enhancing driver comfort and performance. The Fast Track's capability is not just theoretical. With a plow on the front and a snowblower on the back, it can efficiently clear snow at impressive speeds. This combination of speed, comfort, and functionality makes the JCB Fast Track a formidable machine in snow removal operations. The Tupo 8E Control Plus is revolutionizing the world of wall plastering with its unparalleled speed and efficiency. Hailed as the most advanced wall plastering machine ever invented, the Tupo 8 boasts the capability to plaster an astonishing 200 square meters of walls per hour. This remarkable performance makes it the fastest rendering machine globally. Key to its exceptional functionality are its foldable lateral poles, which enhance mobility and make the machine easy to maneuver. The Tupo 8 features a digital auto-positioning system that ensures perfect alignment, eliminating human error and ensuring a flawless finish every time. The machine's extra-large mortar tray is designed for convenience, allowing easy refilling directly from a wheelbarrow. Using the Tupo 8 is incredibly simple. With just a press of the start button, you can plaster an entire section of a wall in mere seconds. The Tupo 8E Control Plus power and efficiency are unmatched. It can complete an entire wall in just a few minutes. This capability not only saves time but also significantly reduces labor costs and increases productivity. The road printer bricklaying machine revolutionizes road construction with its efficient modular design. Available in divisible widths of 4, 5, and 6 meters, this innovative machine can pave entire roads, including edge finishing, in a single pass. Its adjustable road width feature allows it to accommodate all widths from 1 to 6 meters, providing flexibility for various project requirements. A standout feature of the road printer is its leveling tray, which ensures a perfectly screeded and leveled surface before paving. This results in a smoother, more uniform finish and significantly reduces the need for manual adjustments, saving both time and labor costs. The road printer's ability to lay a continuous stretch of bricks seamlessly enhances productivity and consistency in road construction projects. This machine not only improves the efficiency of paving but also reduces the environmental impact by minimizing waste and the need for additional materials. Its robust construction and advanced technology make the road printer an ideal choice for contractors seeking to streamline their operations and deliver high-quality results. By integrating this machine into their workflows, road construction companies can achieve faster completion times and superior pavement quality, setting new standards in the industry. Follow the team as they work to bring this old parking lot back from the brink of complete collapse. Located on Indian Rocks Beach in Largo, just south of Clearwater, this project showcases the latest in sustainable asphalt techniques, emphasizing the use of recycled asphalt pavement, RAP, and other innovative methods. In the face of climate change and resource depletion, industries worldwide are rethinking their practices to embrace sustainability. One significant contributor to environmental impact is the construction sector, which is now undergoing a crucial transformation. Asphalt paving, traditionally reliant on virgin materials and energy-intensive processes, is one area ripe for change. Emerging techniques aim to enhance pavement performance, sustainability, and even aesthetics. RAP and innovative paving methods are game changers, paving the way for a greener future. Imagine mountains of discarded asphalt pavements destined for landfills. This was the reality until RAP gained traction. RAP refers to reclaimed or recycled asphalt pavement, essentially milled up old roads repurposed for new ones. This remarkable practice offers a plethora of benefits. Utilizing RAP significantly reduces the extraction and processing of virgin aggregate, minimizing environmental damage and conserving valuable resources. Additionally, asphalt production is energy-intensive, accounting for substantial greenhouse gas emissions. Replacing virgin materials with RAP drastically reduces this carbon footprint. Furthermore, RAP is often cheaper than virgin materials, translating to cost savings for construction projects. Studies have shown that well-designed RAP mixtures can perform on par with traditional asphalt pavements, sometimes even exceeding their lifespan. RAP can improve pavement stiffness and durability when used in appropriate quantities and mixes. It can also enhance thermal properties, potentially leading to improved crack resistance. However, the use of RAP is not without challenges. RAP quality can vary depending on the source pavement, its age, and maintenance history. Careful testing and control are crucial. High RAP content can sometimes lead to workability issues or reduced flexibility, requiring a careful mix of design and optimization. Additionally, transportation, storage, and handling of RAP require proper planning and infrastructure. Despite these challenges, recent advancements in RAP technology have made significant strides. Technologies now allow for incorporating higher percentages of RAP, up to 70%, in new asphalt mixes, maximizing resource recovery. Rejuvenators, additives that improve the workability and performance of aged RAP, are expanding its potential uses. Some facilities create a closed-loop system where milled asphalt from pavement repairs is directly recycled into new mixes, minimizing waste. While RAP is a crucial tool, it's just one piece of the puzzle. The asphalt paving industry is constantly innovating, developing groundbreaking techniques to further enhance sustainability and performance. Warm mix asphalt, WMA, is one such innovation. This technology reduces the production temperature of asphalt by 50 to 70 degrees Celsius compared to traditional methods, translating to lower energy consumption, reduced emissions, and improved worker safety. Permeable pavements are another innovative solution. These pavements allow rainwater to infiltrate the surface, replenishing groundwater and reducing stormwater runoff. They also mitigate the urban heat island effect, creating cooler city environments. Cold-in-place recycling, CIR, is a technique that recycles existing pavement in situ, eliminating the need for excavation and hauling materials. It saves time and resources and minimizes environmental impact. Research is also exploring the feasibility of pavements containing up to 100% RAP, further maximizing resource conservation and minimizing virgin material use. Other exciting innovations include self-healing asphalt and bio-based binders. Self-healing asphalt mixes contain polymers or additives that can repair minor cracks and sealants that automatically fill larger cracks, extending pavement lifespan and reducing maintenance costs. Bio-based binders, replacing traditional petroleum-based binders with plant-based or bio-derived alternatives, can further reduce the environmental impact of asphalt paving.
In Gampelin, the process of lowering a gas pipeline was executed using a Liebherr A924 Latronic wheeled excavator, optimized for utility applications. The task involved precise excavation and repositioning of an existing buried gas pipeline to accommodate new infrastructure or comply with updated safety standards. The Liebherr 924, equipped with a hydraulic tilt rotator and a grading bucket, provided the flexibility and control necessary to work around existing utilities in sensitive terrain. After careful identification and exposure of the pipeline using soft excavation techniques, the pipe was temporarily supported and maneuvered into its new position with minimal stress. The trench depth was adjusted according to the revised alignment, and bedding materials were compacted to ensure consistent support. The Liebherr's high lifting capacity and 360 degrees rotation allowed for efficient handling of heavy protective slabs and fill materials. Once repositioned, the pipeline was reburied with appropriate marking and protection layers. The operation emphasized safety, precision, and environmental compliance, demonstrating how modern hydraulic excavators, like the Liebherr 924, are essential tools in utility retrofit projects requiring careful manipulation of critical underground infrastructure. The Nematec pipe lifter is a sewer pipe clamp that operates without hydraulics and connects via a quick coupler. It grips pipes by their ends, allowing pipes to be pushed directly. The pipe lifter holds the sewer pipe at a 25 craned angle, enabling it to navigate most obstacles smoothly. This angled positioning ensures stable transport and enhances safety during handling. Its design improves efficiency and control on site, making pipe installation faster and safer in challenging environments. Atlas manufactures straight seam ERW pipe piles, using 100% North American hot-rolled coil steel. The process begins with slitting coils to the required diameter, then feeding them into a continuous production line. The steel is uncoiled, joined, and shaped into a U profile by forming rollers. Convex and concave rollers align the edges, preparing them for electric resistance welding, ERW, where copper contacts pass current through the strip edges to create a precise longitudinal weld. Excess weld material is scarfed off, and the pipe is cooled and straightened. Ultrasonic testing ensures weld integrity, followed by marking the pipe with a unique heat number for full traceability. Pipes are cut to length using a rail-mounted saw. Final destructive tests confirm strength and ductility. Pipes are bar-coded and shipped with certified mill test reports. The backfill process on a pipeline right-of-way begins once the pipe has been fully welded and tested. A ditching machine, typically equipped with a bucket wheel, excavates a consistent and well-shaped trench to receive the pipe. Side booms then gently lower the welded pipeline into the ditch, ensuring alignment and preventing damage. As this occurs, laborers retrieve wooden skids that were previously used to support the pipe during welding. These skids are collected and stacked systematically, often 600 to 800 per sloop, to be reused or removed from the site. In sections where buoyancy could become an issue, such as near wetlands or water crossings, saddlebag weights are installed over the pipe to ensure it remains properly seated. Backhoes then carefully begin to bury the pipeline, placing the soil back in controlled lifts to prevent damage. Bulldozers follow to groom the right-of-way, forming a berm above the trench to allow for natural settling and erosion control. With the pipe securely in the ground, the site is stabilized and left ready for restoration crews to return in the spring for final grading, seeding, and environmental reclamation.